get going. So basically, we've already talked about the identifying the commits for that are basically responsible for performance regression, and this was done through manual inspection and threshold-based system. And we also had the talk last year that David talked about the system in length. So I also encourage you to check out his work. And so I'm going to be pretty quick, and we're going to present our change point detection, which is based in part on things that Andre also presented, but also shows how our work in the spec research group actually led to this. So we looked at the time series features of the data that we had at hand. Then we applied a voting system. We applied the performance list API, and then what we do is we use XGBoost to achieve basically we throw all of this together in XGBoost to achieve 83% accuracy in that change point detection. So basically, the time series features, this is what Andre already showed you before. So we looked at the mean, we looked at the standard deviation, first, alpha, and beta. And this is done, so we will look at this before and after the change point to basically categorize how the system behaves before and after the change point has occurred. And we then perform statistical analysis on the classified and misclassified change points, so the true, falses, and so on. And what we also do is we measure the change point across different projects. And here what we've seen is that basically they, interestingly enough, perform quite similar apart from one exception. So this is also quite interesting in a sense of how the systems behave in different projects and how a change point behavior is observed through different projects in the MongoDB commits, which of course then in a sense speaks to generalizability, which is very important. So what we have as a system is a quite interesting case, in my opinion, for ensembling these things, and this is also why it might be an easy application or an easy fix in the Mongo ecosystem. So basically, what we've already talked about the time series extraction of the feature before and after the change points, and those features that we calculate using the standard deviation mean and so on. And what we then basically do is we apply this multi-voting approach to predict if, based on those features, this might be a change point or not. And what we then do in parallel is basically we use the same data, the same annotated data, and we apply the performance list API, which we also of course encourage you to use, which is it's available in Python code for everyone to use. And we do the same thing and try to detect the annotated change points that are gone through using the performance list API. And what we've also seen is that we found much more non-annotated change points, which of course is quite difficult to verify, but still it's worth exploring, I think. And what we then do is we combine those two together using XGBoost, which for the results yields us much better performance. You can see here if we only apply the systems as there is, and you can definitely see the improvement that can be made here, or that can be the resulting improvement when using this ensembling of the voting, the performance, so basically a change point detection off the shelf, more or less change point detection, together with then thrown into XGBoost. And I think the most important part here is that first of all, this is a multifaceted approach where we use the several components of several research that we've done before, and it's very lightweight. And as you can see, the results speak for themselves. I think not only is there an increase, but you can also use them as is, I would say. And with that, I would like to thank you, and I'm open for questions. And of course, come join our SpecRG working group for predictive data analytics. We meet every Wednesday, and we're working on standardization and real-world problems, as you can see here. Looking forward to your questions.
All right, thanks a lot, Mark.